Hello everyone, I'm Shivani and welcome to Civil Series. This video covers every important point from surveying subject. Before going to BMC exam for JE and sub-engineer, must watch this video. It covers every important point from surveying and with minimum time you cover most of the points. So let's start the video. So here are the basic definition of surveying and these are the diagrams for the definition. Earth has a oblate spheroid shape, means oval shape. Earth has a two axis, equatorial axis and polar axis. Equatorial axis is horizontal axis and polar axis is vertical axis. अब ये equatorial axis है वो larger है than polar axis. Equatorial axis is larger than polar axis by 43.434 kilometers. Okay. Then next is plane surveying and geodetic surveying. Both the surveyings are differentiated with the help of only 2 points. So first is a plane surveying and second is geodetic surveying. अब जब plane surveying हम करते हैं तो वो हम सिर्फ small areas के लिए find out करते हैं. ठीक है, मतलब अगर हमारा एरिया 250 किलोमीटर से कम हो तब हम प्लेन सर्वेइंग कैरिड आउट करते हैं. बट प्लेन सर्वेइंग में हम अर्थ सरफेस को एज अ प्लेन कंसिडर करते हैं. बट इन केस ऑफ जियोडेटिक सर्वेइंग वी आर कंसिडरिंग दैट अर्थ सरफेस एज अ कर्व्ड सरफेस. एंड जियोडेटिक सर्वेइंग हम लार्ज एरियाज के लिए फाइंड आउट करते हैं. मतलब अगर एरिया 250 किलोमीटर से ज्यादा हो तब हम जियोडेटिक सर्वेइंग कैरिड आउट करते हैं. प्लेन सर्वेइंग में प्लेन कंसिडर करते हैं. इसका मतलब अगर किसी अर्थ सरफेस का एरिया 250 किलोमीटर से कम हो और वहां पे हमें सर्वेइंग कैरिड आउट करनी है तो क्या करेंगे हम. अगर फॉर एग्जांपल उस एरिया पर हम 3 पॉइंट्स ड्रॉ करें और वो 3 पॉइंट्स लाइन की मदद से ज्वाइन करें तो वो जो ट्रायंगल फॉर्म होता है वो एग्जैक्टली प्लेन ट्रायंगल फॉर्म होता है इन केस ऑफ प्लेन सर्वेइंग. बट अगर हमारा एरिया 250 किलोमीटर से ज्यादा है, मोर देन 250 किलोमीटर्स है, तब हम वो 3 पॉइंट्स कंसिडर करते हैं. तो उस वक्त हमारा जो ट्रायंगल फॉर्म होता है उन 3 पॉइंट्स की मदद से तब वो स्पेरिकल ट्रायंगल फॉर्म होता है. ठीक है, तो इसलिए अगर एरिया 250 किलोमीटर से ज्यादा है तब हम कर्वेचर कंसिडर करते हैं फॉर जियोडेटिक सर्वेइंग. और अगर हमारा एरिया 250 किलोमीटर से कम है तब हम प्लेन सरफेस कंसिडर करते हैं इन केस ऑफ प्लेन सर्वेइंग. फॉर एग्जांपल अब इस इमेज में देखिए, अब ये एरिया 250 किलोमीटर से कम है तो इस एरिया के लिए हम क्या करेंगे, प्लेन सर्वेइंग कैरिड आउट कर सकते हैं. ठीक है, तो प्लेन सर्वेइंग हम 250 किलोमीटर के एरिया से अगर कम हो वो एरिया 250 किलोमीटर से तब हम वहां पे प्लेन सर्वेइंग फाइंड आउट कर सकते हैं. प्लेन सर्वेइंग से जो भी हमें वैल्यू चाहिए वो हम फाइंड आउट कर सकते हैं. बट अगर एरिया 250 किलोमीटर से ज्यादा है, मतलब अगर हमें सर्वेइंग किसी कंट्री की करनी हो या फिर किसी स्टेट की करनी हो या फिर किसी डिस्ट्रिक्ट की करनी हो जिसका एरिया 250 किलोमीटर से ज्यादा है तो वहां पर हम जियोडेटिक सर्वेइंग का यूज करेंगे. ठीक है, सो दिस इज बेसिक डिफरेंस बिटवीन प्लेन सर्वेइंग एंड जियोडेटिक सर्वेइंग. Of surveying and the functional classification. So first surveying हमने horizontal distances, vertical distances, horizontal angle, vertical angle फाइंड आउट करने के लिए यूज की थी. ठीक है, मतलब ये चारों वैल्यू हम सर्वेइंग की हेल्प से फाइंड आउट कर सकते हैं. अर्थ सरफेस के अबाउ, ऑन द सरफेस और बिलो द सरफेस. ठीक है, ये चारों वैल्यू हम फाइंड आउट कर सकते हैं विद द हेल्प ऑफ सर्वेइंग. अब इस सर्वेइंग को और भी एक्यूरेसी देने के लिए हमने 2 प्रिंसिपल्स यूज करने हैं. ठीक है, तो उसमें से जो फर्स्ट है वो है वर्क फ्रॉम होल टू पार्ट. वर्क फ्रॉम होल टू पार्ट मतलब जिस भी एरिया के लिए आप सर्वेइंग कैरिड आउट कर रहे हैं तो उस होल एरिया से आपको पार्ट्स में वो एरिया डिवाइड करना है और फिर सर्वेइंग कैरिड आउट करनी है. ठीक है, तो यहाँ पे अगर ये आपका अनइवन एरिया है, ठीक है, ये ग्रीन कलर में जो है वो आपका अनइवन एरिया है और इस अनइवन एरिया पर अगर आपको सर्वेइंग कैरिड आउट करनी है तो पहले इस एरिया को हमें इवन एरिया बनाना पड़ेगा. तो उसके लिए यहाँ पे हम कंट्रोल पॉइंट्स ड्रॉ करेंगे जो मैक्सिमम एरिया कवर कर सकते हैं, ठीक है, लाइक दिस। तो वो कंट्रोल पॉइंट्स हमने यहाँ पे ज्वाइन कर लिए, तो हमें ये इतना एरिया इस अनइवन एरिया से इवन एरिया मिल गया, ठीक है। अब ये इतना जो एरिया है उसे हम ट्रायंगल्स में डिवाइड करेंगे। पहले हम मेजर ट्रायंगल्स में डिवाइड करेंगे, फिर मेजर ट्रायंगल्स को स्मॉलर ट्रायंगल में या माइनर ट्रायंगल में डिवाइड करेंगे, ठीक है। अब ये ब्लैक लाइन जो डॉटेड लाइन है वो हमने क्या किया कि कंट्रोल पॉइंट्स हमने कनेक्ट कर लिए, ठीक है। तो कंट्रोल पॉइंट कनेक्ट करने के बाद हमें मेजर ट्रायंगल्स मिल गए यहाँ पे, फर्स्ट सेकंड थर्ड फोर्थ, ये 4 ट्रायंगल मिल गए। फिर ये जो मेजर ट्रायंगल है उसे हमने और एक बार डिवाइड किया, तो यहाँ पे हमें माइनर ट्रायंगल्स मिल गए, ठीक है। तो यहाँ पे हम क्या कर रहे हैं, पूरे एरिया से स्मॉल ट्रायंगल्स कलेक्ट कर रहे हैं और उससे हम सर्विंग कैरिड आउट कर रहे हैं, ठीक है। अब ये जो एरिया, ये जो मेथड हम यूज कर रहे हैं उसका यूज क्या होगा, सबसे पहले तो हमें एक्यूरेसी मिलेगी, क्योंकि अगर पूरे एरिया के लिए हम सर्वेइंग कैरिड आउट कर रहे हैं तो क्या होगा कि अगर हमारी कैलकुलेशन करते वक्त कुछ गलती हुई तो क्या होगा कि हमें पूरी सर्वेइंग फिर से करनी पड़ेगी। पर अगर सिर्फ इस एरिया में अगर हमारी कैलकुलेशंस गलत हो तो हम सर्वेइंग फिर से सिर्फ इसी एरिया के लिए करेंगे, तो यहाँ पे हमारा टाइम भी कंज्यूम हो रहा है और जो प्रोसीजर हम सर्वेइंग के लिए कर रहे हैं वो भी एक्यूरेट हो गए, ठीक है। तो सेकेंड प्रिंसिपल है to fix or locate a new station point or station by at least 2 independent measurements or process। अगर हमें कोई एक पॉइंट फिक्स करना है तो यहाँ पे हमें 2 फिक्स पॉइंट, मतलब कोई स्ट्रक्चर या फिर कोई बिल्डिंग जिसका यूज करके हमें थर्ड जो पॉइंट है वो फाइंड आउट करना है, ठीक है। 2 मेथड से हम कर सकते हैं, एक कर सकते हैं बाय लीनियर मेथड और दूसरे बाय एंगुलर मेथड। लीनियर मेथड हम चेनिंग से कर सकते हैं और एंगुलर मेथड हम थियोडोलाइट और कंपास से कर सकते हैं, ठीक है। तो यहाँ पे इस फिगर में क्या है, पी और क्यू जो पॉइंट है वो फिक्स पॉइंट है। इन 2 पॉइंट से हमने आर पॉइंट फाइंड आउट किया है, यहाँ पे हम लीनियरली फाइंड आउट कर रहे हैं और यहाँ ये चारों फिगर में हम एंगुलर मेथड से फाइंड आउट कर रहे हैं, ठीक है। सो दिस इज द सेकेंड प्रिंसिपल ऑफ सर्वेइंग। फर्स्ट इज वर्क फ्रॉम होल टू पार्ट एंड सेकेंड इज टू फिक्स or locate a new point or station point by at least 2 independent measurements or process। Functional classification. The classification of surveying is done on the basis of function. Okay. So first is the control survey. In control surveying, we are establishing a horizontal and vertical positions on widely spaced control points। मतलब जो widely spaced control points है उसकी मदद से हम horizontal और vertical positions find out कर सकते हैं under the control surveying। Then second is land surveying. Land surveying is also called as cadastral surveying. Okay, so this type of surveying is used to determine the boundaries and the area of land. Then third is city survey. City survey is used to carry out the layout of streets, pipes and buildings. Then fourth is the topographical surveying. This topographical surveying is basically carried out to find out the natural features of earth. Then next is a hydrographic surveying. This hydrographic surveying is used to establish a water flow in case of rivers, and also used to find out the areas which is below the water surface. Okay. Then next is engineering survey. This survey is carried out to plan and design the engineering works. Engineering works means building, street, bridges, dams, reservoir. For all these type of structures, for planning and designing of these type of a structure, engineering survey is carried out. Then next is astronomic survey. From this astronomic survey, we determine the latitude, longitude, azimuths means true bearing. On the basis of heavenly bodies, stars and sun, we find out latitude, departure, azimuths and longitudes. So these are the 7 functional classifications. Okay, these are the 7 surveying types or classification which is based on functioning. Control surveying, land surveying, city survey, topographical survey, hydrographic survey, engineering survey and astronomic survey. स्केल ऑफ मैप इज अ रेशियो ऑफ मैप डिस्टेंस टू ग्राउंड डिस्टेंस. अब ये जो स्केल ऑफ मैप है वो हम हर किसी प्लान को या फिर हर किसी मैप को ड्रॉ करने के लिए यूज करते हैं. ठीक है, मतलब जो कोई भी ग्राउंड का डिस्टेंस है उस ग्राउंड के डिस्टेंस को हम एज इट इज तो मैप पे नहीं कर सकते या फिर मैप पे प्लॉट तो नहीं कर सकते. उसके लिए हमें उसकी रिड्यूस स्केल करनी पड़ेगी, मतलब उस स्केल से हम कम स्केल मैप पे ड्रॉ करेंगे. ठीक है, तो वो हम 3 तरीके से स्केल ऑफ मैप बना सकते हैं. तो उसमें से पहला है लार्ज स्केल. लार्ज स्केल इज 1 सेंटीमीटर इज लेस देन और इक्वल टू 10 मीटर. यहाँ पे एग्जाम्पल के लिए हमने 10 मीटर 100 मीटर लिया है. ठीक है, डिस्टेंस चेंज भी हो सकते हैं. लार्ज स्केल एग्जाम्पल इज 10 मीटर ऑन अ ग्राउंड इज इक्वल्स टू 1 सेंटीमीटर ऑन मैप. मतलब ग्राउंड का हर 10 मीटर आप मैप पे हर 1 सेंटीमीटर से रिप्रेजेंट करेंगे, तब वो आएगी आपकी लार्ज स्केल. ठीक है. सेकेंड है मीडियम स्केल. अब मीडियम स्केल में है 1 सेंटीमीटर इज इक्वल्स टू 10 मीटर टू 100 मीटर. एग्जाम्पल यहाँ पे हम लेते हैं एग्जाम्पल 60 मीटर ऑन ग्राउंड इज इक्वल्स टू 1 सेंटीमीटर ऑन मैप. मतलब ग्राउंड का हर 60 मीटर हम मैप पे 1 सेंटीमीटर से रिप्रेजेंट करेंगे, तब वो आएगा आपका मीडियम स्केल. ठीक है. लास्ट है स्मॉल स्केल. स्मॉल स्केल 1 सेंटीमीटर इज ग्रेटर देन और इक्वल टू 100 मीटर. मतलब यहाँ पे हम एग्जाम्पल के लिए दे रहे हैं कि डिस्टेंस अगर आपका ग्राउंड का 130 मीटर है तो वो हर 130 मीटर के लिए आप 1 सेंटीमीटर ड्रॉ करेंगे आपके मैप पर. ठीक है. अब ये तीनों एग्जाम्पल से आपको आइडिया क्लियर हो रही होगी कि जब हम कम डिस्टेंस के लिए 1 सेंटीमीटर ले रहे हैं मतलब हमारी स्केल वहां पे लार्ज हो रही है. ठीक है, मतलब अगर लार्ज स्केल की मदद से हम मैप ड्रॉ कर रहे हैं और हमारा डिस्टेंस अगर 100 मीटर होगा. ठीक है, अगर 100 मीटर डिस्टेंस है और वहां पे हमने लार्ज स्केल यूज की है. ठीक है, तो यहाँ पे क्या है कि हर 10 मीटर के लिए आपको 1 सेंटीमीटर लेना है. मतलब अगर आपको 100 मीटर की लाइन ड्रॉ करनी है तो आपको क्या करना पड़ेगा कि मैप पर 10 सेंटीमीटर दिखाना पड़ेगा. ठीक है, तब वो आएगी आपकी लार्ज स्केल. ठीक है. अब सेकंड में क्या है कि यहाँ पे हमने एग्जांपल के लिए क्या लिए है कि हमें 100 मीटर की लाइन यहाँ पे ड्रॉ करनी है. ठीक है. अब यहाँ पे हमने लिया है कि 60 मीटर ऑन अ ग्राउंड इज इक्वल्स टू 1 सेंटीमीटर ऑन अ मैप. मतलब हर 60 मीटर के लिए आप 1 सेंटीमीटर ले रहे हैं. ठीक है, तो यहाँ पे आपका क्या है 100 मीटर, मतलब 60 मीटर के लिए आप 1 सेंटीमीटर ले रहे हो और जो बाकी 40 मीटर है उसके लिए आप 1 सेंटीमीटर से कम लाइन लेंगे. ठीक है. अब यहाँ पे जो स्मॉल स्केल है यहाँ पे हमने लिए कि 130 मीटर के लिए जो ग्राउंड पर 130 मीटर का डिस्टेंस है उसके लिए हमने 1 सेंटीमीटर लिया है, बट एक्चुअल में हमने जो एग्जाम्पल के लिए लिया है वो है 100 मीटर. अब 100 मीटर के लिए हम 1 सेंटीमीटर से कम लाइन लेंगे. मतलब प्लान पर या फिर मैप पर जो भी आपका डिस्टेंस ड्रॉ हो रहा है वो बहुत स्मॉल स्केल में ड्रॉ हो रहा है, इसलिए वो होगी स्मॉल स्केल. ठीक है. Next is a representation of a scale. So there are 3 ways to represent a scale. First is a engineer scale. Engineer scale is represent like this. 1 centimeter is equals to 50 meter. Second is representative fraction. In case of representative fraction, we just need to change the engineer scale into fraction or into proportion like this. So the 1 centimeter is equals to 50 meter in engineer scale is represented as 1 by 5000 or 1 as to 5000 in representative fraction. So you need to be careful in representative fraction that the numerator unit is same as the denominator unit or vice versa. And the last one is graphical scale. In case of graphical scale, the construction of a map by drawing a line or marking the ground distance directly on it means the distance on a ground is draw or plot exactly on a map is the graphical scale. So usually we use the engineer scale and representative fraction than graphical scale for the representation of scales. Then this is a question based on a scale of map and representation of scale. Question is, which of the following scale is largest one? So there are four options, and for checking all the four options, we need to convert all the four options in engineer scale. So first option is 1 centimeter is equals to 50 meter. So this option is in engineer scale. Then second option is in representative fraction. So 1 as to 42,000. So in a representative fraction, the numerator and denominator are in same unit. So here if we consider the 1 as a in centimeter, then convert the 42,000 centimeter into meter. So 1 centimeter is equals to 420 meter. Then third option is also in a representative fraction. So here after converting, 1 centimeter is equals to 3000 meter. So both the units are in centimeter here, and you need to convert the second term into meters for engineer scale. And third is 1 centimeter is equals to 50 kilometers. So convert this 50 kilometers into meters. The option is 1 centimeter is equals to 50,000 meters. By comparing all the four options, we observe that the largest scale is the option A, because here for each 50 meter we need to plot a 1 centimeter line. So this option A is the correct option. Then type of measuring scale. So there are three types of measuring scale. First is a plane scale. This plane scale is able to determine the distances in meter and decimeter. Second is diagonal scale. This diagonal scale is used to determine the distances in meter, decimeter and centimeter. And the last one is chord scale. So this chord scale is used to measure or set out the angles without protector, and chord scale is in rectangular shape. So and the graduations are from 0 to 90 degree. Next is a use of vernier scale. Majorly, there are two types of a scale, main scale and vernier scale. Main scale is that scale which is used to determine the distances, and vernier scale is used to determine the smallest divisions of that distances. Okay, and the value of that smallest division is found out by list count. And the formula for the list count is, first, the formula for the list count of main scale is a ratio of small reading on main scale to the number of divisions on main scale. And second formula is instrument list count. Okay, this instrument list count is the combination, or the this formula is the combination of main scale and vernier scale, which is equals to the ratio of main scale list count to the division of secondary scale. That secondary scale is here a vernier scale. Okay, so this in this image, the upper scale is a main scale and the lower scale is a vernier scale. Okay, the divisions on this upper scale are in centimeters, and in this formula, first we need to find out the smallest reading on the main scale. So smallest reading on this main scale is 1 centimeter. Okay, from 0 to 1, 1 centimeter, 1 to 2, 1 centimeter. Okay, so here we consider a 1 centimeter, and if we convert a 1 centimeter into mm, then that is equals to 10 mm. Okay, for 1 centimeter there are 10 divisions. Okay, here we need to mention the number of divisions on a main scale. So the list count of a main scale is 10 mm by 10 equals to 1 mm. This 10 mm is a distance between 0 to 1, and this 10 is a division between 0 to 1. The list count of a main scale is 1 mm. अब लिस्ट काउंट 1 mm है, इसका मतलब इस स्केल से हम जो सबसे छोटा मेजरमेंट कर सकते हैं वो है 1 mm तक का मेजरमेंट. ठीक है, तो उसे कहते हैं हम लिस्ट काउंट. अब सेम हम फाइंड आउट करेंगे फॉर द इंस्ट्रूमेंट लिस्ट काउंट. ओके, अब यहाँ पे मेन स्केल लिस्ट काउंट कितना आया था 1 mm एंड द डिवीजन ऑफ सेकेंडरी स्केल. अब सेकेंडरी स्केल के डिविजन हमें फाइंड आउट करने हैं. तो यहाँ पे देखो, ये 0 से 1 तक, 0 जो वर्नियर स्केल है उसके 0 से 1 तक यहाँ पे एक डिवीजन बनता है. ठीक है, और यहाँ पे सेकेंड डिवीजन बनता है. तो यहाँ पे दो डिविजन्स है इन 1 mm. ओके, तो यहाँ पे हमारा फॉर्मूला क्या आएगा कि 1 mm में 2 डिविजन है। इसका मतलब जो इंस्ट्रूमेंट का मतलब पूरे इंस्ट्रूमेंट का जो लिस्ट काउंट है वो है 0.5 mm। मतलब इस इंस्ट्रूमेंट से हम 0.5 mm तक का शॉर्टेस्ट डिस्टेंस फाइंड आउट कर सकते हैं, ठीक है। और इस तरीके का भी एक जो मेन स्केल और वर्नियर स्केल होता है वो थियोडोलाइट में प्रेजेंट होता है। और यहाँ पे मैंने कुछ एग्जांपल्स के लिए कुछ सर्वे इंस्ट्रूमेंट्स का जो लिस्ट काउंट है वो यहाँ पे मेंशन किया है। वैसे लेवलिंग स्टाफ, प्रिज्मेटिक, कंपास, थियोडोलाइट, टोटल स्टेशन, ऑल द इंस्ट्रूमेंट्स आर वेल नोन टू यू एंड द लिस्ट काउंट ऑफ लेवलिंग स्टाफ इज 5 mm, prismatic compass is 30 minute, theodolite is 20 second and total station is 1 second. I think you all know how to find the values or how to measure the distances with the help of a vernier scale. And if you don't know about it, then I will definitely make a one video on it. But for that, you need to comment that you want such kind of video. And okay, then move to the next part of this video. So vernier scale has a 4 types. First is a direct vernier. The divisions of direct vernier are shorter than the main scale. मतलब मेन स्केल से डायरेक्ट वर्नियर की डिविजन्स जो है वो शॉर्टर है, ठीक है। सेकेंड पॉइंट इज इंक्रीज इन अ सेम डायरेक्शन। अब यहाँ पे अगर मेन स्केल से हम कोई डिस्टेंस मेजर कर रहे हैं तो वो डिस्टेंस हम कैसे कैसे मेजर करते हैं कि लेफ्ट से राइट तक हम वो डिस्टेंस मेजर करते हैं। अगर उसी डायरेक्शन में हमारा वर्नियर भी मूव हो रहा है तो उसे हम कहते हैं डायरेक्ट वर्नियर, ओके। And then this is the formula to find out the divisions of a direct vernier. NV is equals to n minus 1 s. Okay, this NV is a number of divisions of vernier and n minus 1 s is equals to n minus 1 divisions of main scale. For example, if here we consider a 10 divisions of vernier, ठीक है, n is equals to और n की वैल्यू हम 10 कंसिडर करते हैं, मतलब 10V 10 divisions of vernier is equals to 10 minus 1 means 9 divisions of main scale, okay. 10 divisions of vernier is equals to 9 divisions of main scale. This image clearly shows that the main scale is larger than the vernier scale. So this is the direct vernier. Then second is retrograde vernier. Retrograde vernier, the divisions of retrograde vernier are longer than the main scale. ओके यहाँ से हम रिवर्स करेंगे। मतलब डायरेक्ट वर्नियर में क्या था कि डायरेक्ट वर्नियर की जो डिविजन्स है वो शॉर्टर थी मेन स्केल से। रेट्रोग्रेड में क्या है कि जो वर्नियर की डिविजन्स है वो लॉन्गर है देन द मेन स्केल, ओके। सेकेंड पॉइंट इज इंक्रीज इन अपोजिट डायरेक्शन। अब यहाँ पे डायरेक्ट में क्या था कि लेफ्ट से राइट तक अगर हम मेन स्केल मेजर कर रहे थे तो उसी डायरेक्शन में हमारा डायरेक्ट वर्नियर भी मूव हो रहा था। पर रेट्रोग्रेड में क्या होगा कि अपोजिट डायरेक्शन में मूव होगा, मतलब राइट से लेफ्ट तक मूव होगा, ठीक है। उसे हम कहते हैं retrograde vernier, okay. These 2 points are very important if you want to write a difference between direct vernier and retrograde vernier. Then the formula for the retrograde vernier to find out the divisions is NV is equals to n plus 1 s. This NV is a number of divisions of vernier and n plus 1 s is equals to n plus 1 divisions of main scale. And this image shows that the main scale is shorter than the vernier scale. So this is a direct vernier and retrograde vernier. Then third type is extended vernier. The formula for extended vernier is NV is equals to 2n minus 1 s. NV is the number of divisions of vernier and s is the number of division of main scale. For example, if we consider 10 divisions of vernier and that 10 divisions of verniers are equal to 2n minus 1, यहाँ पर n की वैल्यू हमें 10 कंसिडर करनी है। सो 2 into 10 is 20 minus 1 is equals to 19. Means 10 divisions of vernier are equal to 19 divisions of main scale. Okay. So in this image, you observe that vernier scale is larger than the main scale. Then last one is double vernier. This double vernier is a combination of direct and retrograde vernier. Okay. अब यहाँ पर जो हमें इमेज दिखाई दे रही है उस इमेज में क्या है कि जो मेन स्केल है उस पर हमें 2 डायमेंशंस दिखाई दे रहे हैं, ठीक है। मतलब जो अपर डायमेंशन है वो मूव हो रहा है फ्रॉम राइट टू लेफ्ट और जो बॉटम का डायमेंशन है वो मूव हो रहा है फ्रॉम लेफ्ट टू राइट, ठीक है। अब इस वर्नियर का मतलब जो अपर स्केल है वो वर्नियर स्केल है, अगर वो मूव होगी फ्रॉम राइट टू लेफ्ट या फिर राइट लेफ्ट टू राइट, तो उसी डायरेक्शन से हम यहाँ पर अंदाजा लगा सकते हैं कि वो डायरेक्ट वर्नियर है या फिर रेट्रोग्रेड वर्नियर है। इसलिए डबल वर्नियर कॉम्बिनेशन होता है डायरेक्ट एंड रेट्रोग्रेड वर्नियर का। Then the last point of this first unit, which is error due to shrinkage of map. अब ये error due to shrinkage of map हमें क्यों देखना है? तो जैसे कि अभी अगर हम किसी साइट का प्लान बनाएं या फिर मैप बनाएं, तो वो हमारे पास सॉफ्ट कॉपी में अवेलेबल होता है, ठीक है। पर पहले वो सॉफ्ट कॉपी में अवेलेबल नहीं था, क्योंकि हम वो जो मैप है वो पेपर पे डायरेक्टली बनाते थे। तो ठीक है, तो बहुत समय से अगर वो पेपर रखा हुआ है, तो कभी कभी क्या हो जाता था, ड्यू टू एनवायरमेंटल कंडीशन वो जो पेपर है वो श्रिंक हो जाता है, ठीक है। अब उसे श्रिंक होने की वजह से अगर हमने कुछ वहां पे कुछ स्केल रखी भी है, पर वो साइज श्रिंक होने की वजह से हमारे जो एक्चुअल डायमेंशंस है वो करेक्ट नहीं आएंगे। तो वो जो करेक्ट डिस्टेंसेस है या फिर करेक्ट एरिया है, उसे फाइंड आउट करने के लिए जो भी फॉर्मूलाज हमें लगेंगे वो हम अब इसमें देखेंगे। So first formula is shrinkage factor. So shrinkage factor is equals to the shrunk length to the actual length. Shrunk length मतलब जो मैप आपके पास अवेलेबल है उस मैप पर जो लेंथ दिखाई दे रही है आपको, वो shrunk length डिवाइडेड बाय एक्चुअल लेंथ, मतलब उसकी कितनी लेंथ उस पे पहले मेंशन करी गई थी। मतलब वहां पे कुछ डायमेंशंस या फिर कुछ डेटा वहां पे लिखा हुआ होगा, तो उससे आप एक्चुअल लेंथ ले सकते हैं कि इतनी वो एक्चुअल लेंथ थी और इतनी लेंथ वो श्रिंक हो गई है, ठीक है। ये दोनों वैल्यू का अगर आप रेशियो लेंगे तो आपको यहाँ पे श्रिंकेज फैक्टर की वैल्यू फाइंड आउट होगी। सेम आप इसी तरीके से श्रंक रिप्रेजेंटेटिव फ्रैक्शन टू द ओरिजिनल रिप्रेजेंटेटिव फ्रैक्शन, इस फॉर्मूला से भी श्रिंकेज फैक्टर फाइंड आउट कर सकते हैं, ठीक है। आफ्टर फाइंडिंग दिस श्रिंकेज फैक्टर, you must know that the shrinkage factor is always less than unity, okay. And with the help of this shrinkage factor you can find out the correct distance and correct area. So these are the two formulas to find out the correct distance and correct area for the shrinkage of map. Is offset, okay. So offset is used to measure a distance between object, used to measure a distance between object and survey line, okay. Offset is used to measure a distance between object and survey line, okay. There are two type of offset, okay. Consider this is a surface. If we measure the distance in a perpendicular direction, so this is perpendicular offset, perpendicular offset. And if the distance is measured as an inclined form, this is nothing but a oblique offset, angle other than 90 degree, angle other than 90 degree, then this is nothing but a oblique offset, oblique offset, okay. First, if length of that offset is more than 15 meter, then that offset is long offset. And if length of that offset is less than 15 meter, then that is short offset, okay. This is about the offset. One important point is here that how we differentiate the well conditioned triangles and ill conditioned triangles. So first, well conditioned triangles, and second condition is ill conditioned triangles, ill conditions triangle, okay. If angle of the triangle is greater than 30 degree and less than 120 degree, then that condition is well conditioned. If ill condition, if angle is less than 30 degree but angle greater than 120 degree, this condition is nothing but a ill condition. And well conditioned in that theta is greater than 30 degree and theta is less than 120 degree, okay. Then next is next, then these are the some instruments to measure the offset. So first is open crosstalk. open crosstalk is used to measure a perpendicular offset. Okay, used to measure or used to draw the perpendicular offset. Then French crosstalk is used to draw the 45-degree and 90-degree offsets. Then then adjustable crosstalk. This is used to draw angle, any angle offset. Then prism square. This is used to draw the perpendicular offset. And next, side square is also used to draw the perpendicular offset. This prism square is similar to optical square. This prism square is similar to optical square, and the side square is a combination of two telescope. Okay, here the open crosstalk, prism square and side square. Prism square is similar to optical square. All the three are used to measure or used to draw the perpendicular offsets. French crosstalk is used for 45 and 90-degree offset, and adjustable crosstalk is used for any angle. Okay, then next is true meridian. True meridian is a fixed line of reference. True meridian is a fixed line of reference to determine the direction of survey line. True meridian is a fixed line of reference to determine the survey line. True meridian pass through or true meridian line in which the plane is passed through north and south pole. North and south pole. And this true meridian is always constant. Okay. Then next, magnetic meridian. Magnetic meridian is determined by freely floating and balanced magnetic needle. The direction is determined by freely floating and balanced magnetic needle. Okay, here this magnetic meridian plane pass through magnetic north and magnetic south. But this magnetic north and magnetic south pole is not constant. Therefore, this magnetic meridian is not constant. Okay, the next is arbitrary meridian. Arbitrary meridian is any convenient direction towards the permanent mark. Any convenient direction towards the permanent mark. Okay, so this is about the true meridian, magnetic meridian and arbitrary meridian. Then next is deep. Deep is angle between horizontal plane and any magnetic needle. So this inclination is nothing but a deep. Then magnetic declination. Magnetic declination is angle between magnetic meridian and true meridian. So this is what the true meridian, and this is magnetic meridian. Angle between true meridian and magnetic meridian is magnetic declination. Deep is angle between horizontal plane and any magnetic needle. Then these are the four terms which are related to deep and declination. First term is isoclinic line. Isoclinic line are that lines in that deep is same. If deep value is same, then this is nothing but a isoclinic line. If deep is 0, then that lines are aclinic lines. If the magnetic declination is same, then that lines are the isogonic lines. And if we consider this magnetic declination as 0 here, then these lines are nothing but agonic line. So this is all about the true meridian, magnetic meridian, arbitrary meridian, and deep declination, isogonic, isoclinic, and agonic and aclinic line. Then next is, okay, so here the next point is whole circle bearing and reduced bearing. For whole circle bearing, we represent it like a WCB, and this whole circle bearing is also known as azimuthal bearing. Then for reduced bearing, this is also known as quadrantal bearing. quadrantal bearing. Whole circle bearing is measured from north pole in clockwise direction. Reduced bearing is measured from north and from south pole in clockwise and anti-clockwise direction, and in case of south pole in clockwise and anti-clockwise direction. The angle range for the whole circle bearing is 0 degree to 360 degree, and for the reduced bearing the angle range is 0 degree to 90 degree. So this is how we calculate the whole circle bearing and reduced bearing. This is the quadrantal system: first chord, second, third and fourth. In that the WCB is measured like this. This is what the survey line. So value for the RB or the WCB here is, okay, consider this as a 110 degree Celsius. The value for WCB is equals to 110 degree Celsius. Consider this as one quadrant here. If we take the same angle as a WCB here, this is what the survey line. For this survey line, the RB value is, this is what, because we measure the value from the south pole in anti-clockwise direction. But here the value of RB is different from the whole circle bearing. So how to calculate the reduced bearing values from the whole circle bearing? We see the formulas one by one. Take a first condition. This is the quadrant system. In that we take an angle in the first quadrant. This is the survey line. Here angle is 30 degree. For the first condition, the WCB value is 30 degree here, because angle present in the first quadrant. And in case of RB, the value is same as 30 degree, because here we measure the angle from the north pole and in the clockwise direction. So value of WCB and RB is same in the first quadrant. Okay. Then second, if angle is mentioned in the second quadrant, take this angle as a 110 degree Celsius. So value of WCB is clear, that 110 degree Celsius. But for the RB, the value of angle is little bit near to the pole. Here the value of RB, north pole is here, south pole is here. From the south pole the angle is little than the from the north pole. So that's why we take the measurement of the angle from the south pole. So for south pole, this total angle is 180 degree. Okay, so minus the value of WCB from that 180 degree. So here we get the value of reduced bearing. 180 degree minus 110 degree Celsius, which is equals to 70 degree. Okay, this condition is for the second quadrant. This is the formula for the second quadrant. This formula is for the first quadrant. Value of WCB and RB are equal here. Then second condition, if we take the angle in the third quadrant, this is what the angle. Assume this angle as 195 degree. Okay, so WCB value is equals to 195 degree. But for the RB, here RB is measured from the south pole, because south pole is near to it. So that's why this total is nothing but a WCB. And if we minus this 180 degree value, then we get the value of RB. So minus 180 degree here. So RB is equals to 195 minus 180 degree. The RB value is 15 degree here. So this is the formula for the third quadrant. Then next, if we take the same condition here, but the angle is in fourth quadrant. Okay, so total angle from the north pole is, assume this value as 295. Okay, then WCB value is 295 here. But for the RB, the formula is, this total is nothing but a 360 degree. Okay, if we minus the 360 degree and WCB, then we get the RB value. 360 degree minus this 295 is nothing but this RB. So this is the formula for the fourth quadrant. RB is equals to 360 degree minus WCB. Okay, so this is all about the whole circle bearing and reduced bearing. The next is Then next is fore bearing and back bearing. Fore bearing is the bearing of survey line which is measured in the direction of survey work. Bearing of survey line measured in the direction of survey work. Bearing of survey line is measured in the direction of survey work. Back bearing is bearing of survey line measured opposite to the direction of survey work. Measured opposite to the direction of survey work. Okay, this is what the back bearing and fore bearing. Here, this is the one survey line. Okay, so this is the one survey line, and the fore bearing angle is bearing is measured in the direction of survey line. So this is what the theta 1 value, and bearing is measured in the opposite direction is the back bearing. So this is theta 2 here. For this particular line, this is theta 1, means this is the fore bearing for this line, and this is back bearing for this line, which is theta 2. So how to calculate this back bearing and fore bearing? Back bearing is equals to fore bearing. Back bearing is equals to fore bearing plus minus 180 degree. Okay, so how to take this plus and minus here? In case of WCB system, and second in case of reduced bearing system. Okay, in case of WCB system, if the fore bearing is less than 180 degree, if fore bearing is less than 180 degree, take positive sign. If this fore bearing is less than 180 degree, take this as a positive sign here. But this fore bearing is greater than 180 degree, then take it as a minus sign. Okay, so this is how you calculate the WCB. This is how you calculate the back bearing in WCB system. But in case of RB system, okay, if this is the value of the angle in the RB, this is north and this is east. Okay, the angle is, if this angle is 30 degree, okay, north 30 degree east. Okay, one more point is there. Okay, this is WCB system. In that we directly mention the angle as theta is equals to 360 degree, theta is equals to 270 degree. This is in the WCB. But in case of reduced bearing, we represent the angle as north 30 degree east. Okay, so like this, if this is the quadrant, okay, angle is like this is 30 degree, so represent this as north, this is east, north 30 degree east. Okay, if the angle is like this, okay, same, this is the quadrant here. If the angle is like this, so represent it as, this is south, here is the east, so write it as south. Okay, if this is 30 degree, south 30 degree east. Okay, then second, if the angle is like this is the quadrant, angle is in the third quadrant, and this is 30 degree. Okay, this is south, this is west. Okay, represent this as south 30 degree west. Then take the angle in the fourth quadrant like this. So this is near to north pole. So this, if this is 30 degree, represent this like north 30 degree west. So this is how we represent the angles in the reduced bearing. And here the reduced bearing angle is north 30 degree east. And the back bearing in case of RB system is, just take the directions in the opposite sign. This is south, this is west. Okay, south, if this is 30 degree here, south 30 degree west. So this is fore bearing and this is back bearing. So this is how we calculate the fore bearing and back bearing in case of RB system. The topic is leveling. So leveling is used to find out the elevation of given points with respect to the given or assumed datum. Okay, leveling is nothing but finding the elevation between elevation of given points with respect to given or assumed datum. With respect to given or assumed datum, this is nothing but a leveling. In case of leveling, two surveys are done. First one is plane survey, second is geodetic survey. Plane survey is considered when the area is less than 250 meters square, and geodetic survey is considered when the area is more than 250 meters square. In case of plane survey, the plumb lines are parallel. This is the surface and these are the plumb lines on this surface. Okay. In case of geodetic survey, plumb lines intersect at the center of Earth. Plumb lines intersect at center of Earth. Okay, so these are the plumb line in case of geodetic survey. This is the geodetic survey. The next is there are some important terms related to leveling. In that, first one is, okay, before discussing the terms, first we know what the mean sea level. So this is the mean sea level. Mean sea level is nothing but the average height of sea at all stages. Okay, average height of sea at all stages, and datum is nothing but any surface used to find out the elevation. There's nothing but a datum. Datum is any surface used to find out the elevation. Then next, elevation is vertical distance which is above. Okay, this is datum, which is above or below the datum is nothing but elevation. Then last term is benchmark. So benchmark is permanent, fixed or permanent reference point, is nothing but a benchmark to start the survey. So this is the mean sea level, and these are the lines, these are the plumb lines which intersect to the center of Earth. These are the normal plumb line and this is the perpendicular plumb line for this particular figure. If the plumb line is perpendicular, this is also known as vertical line or plumb line. This is also plumb line. These are the three plumb lines here. Then next, any surface parallel to mean sea level is nothing but a level surface. Any surface which is parallel to mean sea level is nothing but a level surface. So this is the level surface. And any line which is parallel to or normal to the level surface or normal to the plumb line is nothing but a level line. So this is level line. Then plane tangential to the level surface. Plane tangential to the level surface is the horizontal plane. Okay, plane which is tangential to the level surface is nothing but a horizontal plane. And any line which is drawn on this vertical or the horizontal plane is nothing but a horizontal line. So this line which is normal to the plumb line but drawn on the horizontal plane, this line is a horizontal line. So these are the few important terms related to leveling. Then next is method of leveling. Here the leveling is differentiated into two parts. First one is indirect leveling. So in case of indirect leveling, three levelings are done. So in that three leveling, first one is barometric leveling. Barometric leveling. So in case of barometric leveling, the difference in elevation, okay, here I represent in a formula. Okay, this is not in a formula, this is in a theoretical form, but for easiness here I represent this barometric leveling into the formula. Okay, so difference in the elevation between 2 points, here I consider first elevation is E1, second elevation is E2. So difference in the elevation between the 2 points is proportional to difference in the atmospheric pressure, which is P1 for first and P2 for the second elevation. Okay, so difference in the elevation between the 2 points is proportional to the difference in the atmospheric pressure. This is the barometric leveling. Then second one, hypsometric leveling. Hypsometric leveling. Okay, so hypsometric leveling is nothing but difference in boiling point. Difference in a boiling point, which is T1 for first and T2 for second. Difference in the boiling point is proportional to the difference in the elevation. Difference in the elevation. This is nothing but a hypsometric leveling. Then third one, trigonometric leveling. Trigonometric leveling. So trigonometric leveling is nothing but, here in case of trigonometric leveling, the elevation of points are determined by, here consider E1 as a elevation. Elevation of a point are determined by the help of vertical angles and horizontal distance. Okay, here we take the vertical angle and horizontal distance ratio to calculate the elevation of points. This is nothing but a trigonometric leveling in a simplest form. Okay, then these are the three levelings done under the indirect leveling. Then next is direct leveling. Then next is direct leveling. So under the direct leveling, there are four levelings. In that, first one is differential leveling. Differential leveling. So differential leveling is difference in the elevation of 2 points. Difference in the elevation of 2 points. Difference in the elevation of 2 points. Then next is profile leveling. Then next is profile leveling. Next is profile leveling. So profile leveling is nothing but a longitudinal leveling. This is also known as longitudinal leveling, and in this the profile leveling is used to determine the elevation of points at measured interval along a given line. Elevation of points at major intervals. Okay, so here first interval, second, third, fourth, measured interval along the line. Okay, along the line. This is nothing but a profile leveling. And third is cross sectioning. Cross sectioning. So in case of cross sectioning, the levels on each side of main line are at right angles to that line. Levels on each side of a main line, at right angle to that line. This is nothing but a cross sectioning. Then next fourth is reciprocal leveling. Reciprocal leveling. In this reciprocal leveling, the instrument is set at the center to eliminate the collimation error. To eliminate collimation error. Okay, so here the difference in the elevation between the 2 points is accurately determined by two sets reciprocal observations. when it is not possible to set the level between 2 points, when it is not possible to set the level between 2 points, then two sets of the reciprocal observations are determined, and from that two sets of reciprocal observations we determine the difference in the elevation. Okay, so here this is the formula to use the true difference in case of reciprocal leveling, which is h is equals to a1 minus b1 plus a2 minus b2 divided by 2. So this is nothing but a true difference in case of reciprocal leveling. So this is all about the methods of leveling, indirect leveling and direct leveling. Then next there are some few important terms. In that, first one is station. So station is the point where staff is held, point where staff is held. So this is the station point. Then next, second is height of instrument. Height of instrument. So height of instrument is plane of sight with respect to assumed datum. Plane of sight with respect to assumed datum. Plane of sight with respect to assumed datum. Then third one is back sight. Third one is back sight. Okay, so here back sight is taken on a staff held at the points of known elevation. Back sight is a sight which is taken on staff, and that held on unknown elevation, held on not unknown, held on known elevation. And this back sight is the first reading. Back sight is the first reading, and back sight is also known as plus sight. Back sight is also known as plus sight. Here, the height of instrument is calculated with the help of backside. Height of instrument is nothing but a benchmark plus backside. Benchmark plus backside. Then next is fourth is free foresight. Next is foresight. So here foresight is a sight taken on a staff held at unknown elevation. Here known elevation, and here foresight is taken on unknown elevation. Unknown elevation. Here RL is equals to, here reduced level is equals to height of instrument minus foresight. Height of instrument minus foresight, and this is also known as minus sight. Also known as minus sight. Okay, here this foresight is last reading. Foresight is last reading. Okay, this is about the backside and foresight. The next term is, fifth term is intermediate sight. Intermediate sight. So intermediate sight are the readings which are in between the backside and foresight. Okay, reading between the backside and foresight are nothing but an intermediate sight. Then next one is change point. Okay, change point is that point in which the same reading, or the point after which the instrument changes its place, is nothing but a change point. Here backside and foresight are taken on the same point. Okay, here backside is taken on that point which is foresight for the before point or the previous point. So this is nothing but a change point. Here we change the instrument station or instrument. Here we change the location of instrument. Okay, this is nothing but a change point. The next term is, the next are the types of levels. In that, first one is tilting level. So tilting level, in case of tilting level, the line of collimation of telescope is parallel to axis of bubble tube. Line of collimation of telescope is parallel to axis of bubble tube. Axis of bubble tube. So this is about the tilting level. In case of tilting level, the leveling is done quickly. So here quick leveling is done. Quick leveling is done. Then next is line of sight can be treated slightly without tilting the vertical axis. Here the line of sight and vertical axis are not perpendicular. Line of sight and vertical axis are not perpendicular. Then next is Y level. In case of Y level, the adjustments can be done rapidly. Here the adjustment in case of this level is done rapidly, but the adjustments are for shorter span. Okay, the adjustment span is very shorter span of adjustment. Then next is reversible level. So reversible level is the combination of dumpy level and Y level. Combination of dumpy level and Y level is nothing but a reversible level. Then next is dumpy level. So here dumpy level has a four components. First one is telescope. So telescope is used for line of sight, to draw the line of sight. Then next is level tube. This is used for the line of sight is horizontal or not. This is used to check the line of sight is horizontal or not. Then third one is leveling head. So this leveling head is used to make the center. Okay, to make the center of that instrument. So this bubble runs to make the center line of the level. Then next is tripod. Tripod is used to support the instrument. Okay, then advantages of this dumpy level are, here this dumpy level is with a movable parts. Then next, the adjustments are very less, fewer adjustments, and these adjustments are last long. So longer life of adjustment. Okay, then next are the adjustments, which are temporary adjustments and permanent adjustment. In that, first we see the temporary adjustments. So temporary adjustments in case of dumpy level are, first one is setting up the level. Then second is leveling up, setting up the level. Next is leveling up. Third is elimination of parallax. Then fourth is focusing the eyepiece. Fourth is focusing. In that, focusing the eyepiece for crosshairs and focusing the objective end for the image of that object. Okay, so these are the temporary adjustment. Then permanent adjustments for this dumpy level are permanent adjustment. So in the permanent adjustment, first one is vertical axis level is perpendicular to axis of bubble tube. Vertical axis level is perpendicular to axis of bubble tube. Then next is line of collimation is perpendicular to vertical axis. Then axis of bubble tube is parallel to line of collimation. Next is axis of telescope. Coincide the line of collimation. Then last is horizontal crosshair is perpendicular to vertical axis. So these are the permanent adjustments for the dumpy level. The next and last point of this video is curvature and refraction error. So in that, first equation is related to curvature correction. curvature correction. So the formula to find out the curvature correction is CC is nothing but a curvature correction. Formula is d square divided by 2r, which is always negative, and this CC is nothing but 0.07849 d square, which is always negative. Okay, so this is about the curvature correction. Here the d square, put this d in meter. Okay, then next is put this d is in kilometers. Okay, not in meter, kilometer. The next formula is about the curvature of refraction, curvature of refraction, curvature of refraction. Cr is equals to d square divided by 2r into 1 by 7. D square divided by 2r into 1 by 7. So Cr is equals to 0.01121 d square. Cr is equals to 0.01121 d square. This d is put in kilometers. Then next third is combined correction. Combined correction. So combined correction is Cc plus Cr. Cc plus Cr. So here Cr is always positive. So here Cc value is minus d square divided by 2r, and Cc value is minus d square divided by 2r, and Cr value is d square divided by 2r into 1 by 7. So this value is minus 6 by 7 d square divided by 2r, and simplification value for this c is equals to 0.06728 d square, 0.06728 d square. Okay, so this is all about the leveling, and leveling is very important topic from the surveying. So this 20 minutes cover your leveling part completely. And okay, so this is the leveling, and thank you for watching the video.